Okay, so welcome back to this next video on distance, rate, time. And in this one, we are going to look at another motion. And just remember, whenever you're doing these questions, you're really trying to look at the motion of the objects involved and also the distance that they cover during that motion. And this question states, a helicopter leaves an airport and flies north at 118 miles per hour. 20 minutes later, a plane leaves the airport and follows the helicopter at 330 miles per hour. How long does it take the plane to overtake the helicopter? Well, in this question, we see something a bit different than the other ones. And in this one, as you see in the graphic, the plane will fly past the helicopter after leaving 20 minutes later, as seen in the little visual graphic. So let's look at how to go about this question. We're going to go about the same steps, but just to kind of keep you abreast, that in the next video, we're going to do these without any of these steps. All right, so let's remember the last part of the question says, how long does it take the plane to overtake the helicopter? Well, step one, we state the type of motion and draw a sketch. Well, we saw the graphic, the visual graphic, and we know that they're heading in the same direction. Now, our sketch is going to look a little bit more descriptive, but you could just draw a little quick airplane and a helicopter just to help you out with coming up with the equation. In step two, the question is asking for the plane's flying time, so we're going to let the basic variable represent the plane's flying time. And since we're looking for time, we're going to let it be t. And that's mainly because it's going to overtake the helicopter. Now, you could have looked for the helicopter speed. It's just that if you do that, you have to make a mental note of what your variables represent at the very end in order to find and replace. I might do that on the next video. For this one, t is going to be equal to the plane's flying time. And so the helicopter's time then would be found by looking at our question where it says 20 minutes later. Now, to find out what the 20 minutes later means as an expression with our variable t, we have to understand exactly what that means. Sometimes this can be a little bit confusing for some learners. The helicopter's flying time will be 20 minutes longer than the plane's flying time because it had left earlier. And so because the plane is going to pass it, it will have more time than the actual t. And it's going to be an extra 20 minutes. So t, the time that the plane will spend flying, plus the extra 20 minutes that the helicopter left. Now, we want to have those 20 minutes written in hours. So we have it as 20 over 60 because there's 20 minutes in an hour and there are 60 minutes in an hour. So 20 over 60 represents a fraction of that hour. If we reduce that to 2 over 6 by reducing those zeros or dividing by 10 on the numerator and the denominator, we can reduce it even further to 1/3. And so t plus a third hour represents the helicopter's flying time. So now we can go about with our next step. Step 3, make a chart organizing the facts and labeling our sketch. Well, we make our table remembering to use our formula distance is equal to rate multiplied by the time. And we're going to do that with our helicopter and plane to find our distances. We know our motion, now we just need our distances. So we know our plane's flying time is represented by t, the helicopter, t plus a third. We know the rate of the helicopter, which is given as 180 miles per hour, and we also know the rate of the helicopter at 330 miles per hour. Now, in order to find the distance traveled relative to the time for the helicopter, well, we simply multiply the rate and the time to get 180 times the quantity t plus a third. Same with the plane, we could do 300 times t, and now we have our representative distances. Now, we need some more room, so I'm just going to move everything up. And the helicopter here is represented by dh, which represents the distance of the helicopter, and then dp, the distance traveled by the plane. Now, what we want to do is use the sketch and our table to write the equation and solve. Now, the way that we can do this is simply think about what's happening when the plane overtakes the helicopter. Well, when the plane overtakes the helicopter, have a little visual again. What will happen is the plane will be at the same point as the helicopter. It would have traveled the same exact distances, or their distances would be equal at the time that the plane overtakes the helicopter. With that stated, we can now come up with a verbal model. The distance the plane travels is equal to the distance the helicopter travels. Well, what is the distance that the plane travels? Well, we already found that. That's 330 t. And that's going to equal to the distance the helicopter travels, which we found as well, which is 180 times the quantity t plus a third. Now that we have our equation, we simply have to solve for t. So making some more room, we're going to go ahead and solve using our order of operations. In order to do this correctly, we need to distribute that 180 into that expression and making sure that every term in the expression gets multiplied. So 180 times the t and 180 times that 1/3. Well, that gives us another expression, a more smoother one. And so you see we have the 180 multiplied by the t plus also the fraction. Now 180 times a third is the same as saying 180 divided by 3. And so that gives us 60. And now we just need to get our t's on the same side because we're solving for t, so we want them on the same side of the equation, and we leave the other like terms on the right side, which is just 60. The way that we'll do that, we need to do the opposite operation to move the 180t, and so we're going to do the opposite, which is negative, or subtraction. With the same number, what we do to one side of the equation, we'll do to the other. The 180t's will cancel out, and 330t minus 180t is going to be 150t equal to 60. We need to do a similar step here. We need to get t by itself. There's multiplication happening between 150 and the t, so we'll divide by the same number we want to remove, and what we do to one side of the equation do to the other. 150's cancel out to 1, and 1t is just t, and 60 over 150 can reduce by dividing both sides by 10, or just canceling those zeros to get 6 over 15. That can reduce even further down to t equals to 2/5. So now that we have the plane's flying time, we need to understand what 2/5 mean. 2/5 is in terms of hours, so this is 2/5 of an hour, or 2/5 of 60 minutes. In order to find out what that is, we can use our understanding of rate in order to get the right unit. So 2/5 of an hour of 60 minutes in an hour, or per hour, cancels out the hours, and we're simply left with 2/5 times 60. And if we do that in a calculator or just in our heads, we will get 24 minutes. And that gives us our final answer, that the plane overtakes the helicopter after 24 minutes. And that's how you do a question where the objects are heading in the same direction. Please tune in as we go over some more problems, but this time we're going to do them without the steps and some more challenging problems. Don't forget to subscribe, to hit the bell notification when a new video comes out, like it, and share it. See you next time.